That way if somebody forgets how to do this, there's a video. All right. So I'm going to do the second one first because that one is a little bit more simple. So as a reminder, the first thing you want to do when you're balancing an equation is you identify where are the reactants and the products. So you look for the arrow. That arrow is the divider between the reactants and the products. Okay, so these are the reactants on this side, and these are the products. All right, the reactants are what we start with, the products are what we end with, just to remind ourselves. Okay, then we looked and see what elements or polyatomic ions that we have. And the reason I'm starting with the second one is because it's just elements. There's no polyatomic ions. There's polyatomic ions in the first one. So we'll get back to that one in a second. All right, so what elements? We're just looking at the letters. And if you forget, take one of those. If you forget what the elements are, because some elements have 2 letters, right? Like beryllium and magnesium, but some only have 1 letter, like hydrogen, right? So you can look at the periodic table to determine what the elements are. Okay, but these are all single letters. If an element has 2 letters in its chemical symbol, one is capital, one is lowercase. All right, so we have K, which is potassium. We don't even need to know the names of these elements to be able to do this. So we just need to identify the elements by letter. And B is boron, and O is oxygen. And we have the same thing on both sides. So we have potassium, boron, oxygen on each side of the equation. Okay, so first step, where's the reactants, where's the products? Second step, what elements do we have? Write them down. Next step, count how many we have. So if there's no subscript, that means we have one of them. There's no subscript on the K, so there's just one potassium atom. There's a subscript of 2 on the boron, so there's 2 borons. And there's a subscript of 3 on the oxygen, so there's 3 oxygens. Okay, then when it comes to the product side, we start counting over because we need to make sure we have the same number of atoms of each element on the product side as the reactant side. So here there's a subscript of 2 on the potassium, so there's 2 potassium atoms. Oxygen, there's no subscript, so there's just one of those guys. No subscript on the boron, so there's one of those guys. Okay, and then we ask ourselves, is it balanced? So there should be the same number of Ks on each side, but there's not. There should be the same number of Bs on each side, but there's not. There should be the same number of Os on each side, but there's not. It's not balanced. Okay, so the only way we can balance is by putting numbers in front of the atoms or the molecules. Those numbers, if you remember, are called coefficients, the big numbers in front. And that's the only thing we can change. All right, you can't change subscripts, you can't add molecules or atoms, but you can just say there's more of each one. All right, so if I'm gonna have 2 Ks on this side, I need to put a coefficient of 2 in front of the K. All right, and then I recount. Now I have 2 Ks on this side, 2 Ks on that side. Now that's balanced. For the boron, there's 2 on this side. If I'm gonna have 2 on this side, I need to put a coefficient of 2, because 2 times 1 gives us 2 borons. So now the borons are balanced. And then I'm gonna look at the oxygens. There's 3 on this side. There's just 1 on this side. I can put a 3 here, because 3 times that 1 oxygen is gonna give us 3 oxygens, but it's also gonna mess with our potassiums, our Ks. 3 times 2, now we have 6 potassium, so we kind of mess that up, but we can just go back. So if I have 6 potassiums on this side, because 3 times 2 is 6, I can go back over here and I can change this coefficient to a 6. And now I have 6 Ks. So now it's balanced. We have 6 Ks on each side, 2 Bs on each side, 3 Os on each side. It's balanced. Okay, my eraser doesn't work that great, but that is a 6. So there's 6 Ks, 1 B2O3. So even though there's no number here, we understand it to be 1. There's 3 K2Os and 2 Bs. Questions? No? All right. So now I'm going to go back to the first one because this one has a little bit of a complication because it has polyatomic ions and they're difficult to see because there's no parentheses. So if you see something in parentheses, for instance, like on number 12, is that still up here? Right. On number 12 here, we have Al and then OH in parentheses with a 3. This is a polyatomic ion. And then same over here, the CO3 in parentheses, the CO3 is a polyatomic ion. That makes it easy to see polyatomic ions, but we don't see that in number 1. Okay, but there are polyatomic ions there. Yeah, there's polyatomic ions there that I can see. And if you have a little bit of experience, you can see them too, but that's why I want to do this one as an example. So what I see here is this PO4 is on, well, first let's identify the reactants and the products. So these are the reactants, these are the products. There's a PO4 on the reactant side and a PO4 on the product side. So if you see it on both sides, you can use that as a polyatomic ion. So what I do is I like to make a box around it. So that makes me think of that as one unit. Think of it as, remember I was saying Legos that have been glued together. So you're just gonna have to take that piece, even though it's like 3 Legos or 5 Legos glued together, you can still use that piece. You just have to use them glued all together. So as long as it's on both sides, then you can use it like that. There's another polyatomic ion that's even more hidden. This OH is the hydroxide ion. We don't see it over here unless we change H2O to HOH. So now if we do that, and it's still H2O, right? 2 H's and an O. If we do that though, we can box this out as a polyatomic ion. And it makes it easier. If we were, you can balance this without boxing out the polyatomic ions, but then you're counting oxygens all over the place. And for me, that's very frustrating. If you find it easier, or for whatever reason you don't identify the polyatomic ion, you can still balance by counting the hydrogens and oxygens separately and the phosphate separately. I feel like it's a little more work. So what else do we have here? We have hydrogen and we have K potassium again. I just like to do them in order. Okay, so now we're gonna count. So there's a subscript of 3 on the hydrogen. And then the PO4, I know there's a little subscript here, but it's inside the box. I'm not gonna count that. We're gonna say how many of these boxes do we have? Only 1 box. There's no parentheses around it, no subscript outside of parentheses, so it's just 1 box. There's no subscript on the K, and then same with the OH. There's 1 OH group. If there were more OH groups, there'd be a parentheses and a little subscript outside the parentheses. Okay, so there's 1 of those guys. For H, this H by itself, there's just 1 of them. Again, this PO4 box, there's only 1 of those boxes. There's a subscript of 3 on the K, so there's 3 Ks. And then the OH, there's only 1 of those guys. There's no parentheses with a subscript outside of it. All right, so we're not balanced because we have 3 hydrogens on this side, only 1 on this side. We have 1 potassium on this side, 3 on that side. The ions are actually balanced, but we still have to balance the hydrogens and the potassiums. All right, so if I have 3 hydrogens on this side, to get 3 hydrogens on this side, I need to put a 3 as a coefficient, right? And that's gonna multiply with this 1 hydrogen to give me 3 hydrogens. And now it's gonna mess with my OH groups, now I have 3 of those too. So 3 times 1 gives me 3. So, I'll go and balance the K's. So I have 3 K's on this side, only 1 on this side. If I put a 3 here, that's going to balance with the K. So now I have 3 K's on each side, but it's also going to multiply with this OH group. 3 times 1 is 3, so that fixes that problem. So we just have 1 of these H3PO4s, 3 KOHs, 1 K3PO4, and 3 H2Os. That's it.